The man who built LLVM, the compiler infrastructure running under almost every programming language you use, just sold his second company to Qualcomm for $3.9 billion. The thing he was selling is a language designed to make the way you write ML code look embarrassing by comparison. On June 24th, 2026, Qualcomm announced it was acquiring Modular. 3 weeks earlier, Chris Lattner had shipped Mojo 1.0 Beta 1 and launched mojolang.org. The timing was not an accident. Stick around for the mechanism. Because the Python isn't dying, story is the wrong frame, and the right one is considerably more unsettling if you're an ML engineer. Also for the honest caveat, because some of what Modular's marketing says is doing real work, and the gap between the claim and the benchmark is worth naming. Start with the problem Mojo actually solves. Because the Python is slow, pitch is the boring version of the story. Everyone knows Python is slow. That's been true for 20 years. The reason ML stayed in Python anyway is that slowness was outsourced. You write the research code in Python, iterate fast, and when it matters, a C++ or CUDA expert rewrites the hot path into something the GPU can actually use. The Python is a front door. The real building is built in a different language by a different person with a different set of skills, and if you're unlucky, that person left the team 6 months ago. This is called the two-language problem, and it is not a minor inconvenience. It is a structural tax on every ML team that has ever tried to move from prototype to production. The research scientist writes in Python. The infrastructure engineer rewrites in C++ or CUDA. They discover the assumptions don't match. They reconcile. They repeat. A 1-week PyTorch experiment can take months to land in production because the production system isn't Python, and the people who can cross that bridge fluently are expensive and rare. Mojo's claim is that the bridge doesn't need to exist. One language, one file, same syntax you already know, compiling to performance within 10 to 20% of hand-tuned C++ or CUDA on most workloads. 3 to 4 orders of magnitude faster than pure Python. 1 to 2 orders of magnitude faster than optimized PyTorch. On memory-bound GPU kernels, a 2025 study from Oak Ridge National Laboratory presented at SC25 found Mojo broadly competitive with CUDA on both NVIDIA and AMD hardware without any additional optimization passes. Gaps remain: compute-bound workloads on AMD, atomic operations, some fast math paths. But the direction of travel is clear. The person who could build this credibly is a short list. Lattner is essentially the entire list. LLVM, Clang, Swift. 3 foundational toolchains, each one changing how an entire ecosystem compiles code. MLR, the compiler framework underneath Mojo, is a next-generation replacement for LLVM IR that lets you define hardware-specific optimization passes at a higher level than was previously possible. Mojo doesn't compile to LLVM and call it done. It compiles through MLIR, which means it can speak natively to tensor cores, bfloat 16 ops, tiled matmuls, the actual primitives that modern AI accelerators expose, and wrap them in Python-style syntax without paying an abstraction penalty. That is what Qualcomm bought, not a language. A software layer that can route AI workloads across NVIDIA, AMD, Intel, ARM, and Qualcomm Silicon from the same source file. The analysis from NAND Research after the acquisition put it plainly. NVIDIA's real moat has never been the GPUs. It's CUDA, the rewrite cost that keeps workloads pinned to their hardware. Every chip company that wanted to compete with NVIDIA had to answer one question first. Why would anyone rewrite their pseudokernels for your hardware? Most never had a good answer. Qualcomm just bought the closest thing to one. Now the honest caveat, because some of Modular's numbers need a footnote. Mojo is not a full Python superset. The language does not support Python's class system. It has struct types instead, which are different and not drop-in replacements. Mojo programs can import and call Python modules via the CPython runtime, which means your NumPy and PyTorch calls still work, but the Mojo code itself is not Python and does not run on the Python interpreter. The compiler is still closed source as of today. Modular has committed to open sourcing it in fall 2026, a deadline that Lattner has been public about wanting to beat. Mojo 1.0 Beta 1 shipped May 7th. It's a beta. Mixture of experts model architectures. The design powering DeepSeek v3, Llama 4, GLM 5.2, and an increasingly large share of frontier deployments are still not fully supported in Macs. That is a real gap in the story, and the benchmark numbers are largely from workloads where MOE isn't involved. Credit where it's due, because the hype isn't pure marketing either. Modular Platform 26.2, released in March, showed a 4x speedup on FLUX.2 image generation. That runs on the same code across NVIDIA Blackwell, AMD RDNA, and Apple Silicon. A developer on the Modular community forum wrote, "I did not expect it to outperform a well-known solution like llama.cpp. That's a community testimonial, not a vendor claim, and llama.cpp is not easy to beat." An academic paper in June 2026 on financial AI workloads concluded that Mojo reaches C++ level performance from the exact source code the research team writes, not a performance-tuned separate codebase. That is the actual promise. Here's the structural reason ML engineers should be paying attention, and it is not Python will be deprecated. That framing is wrong, and the people saying it have courses to sell. The real shift is what Mojo does to the team structure. If a single ML engineer can write a custom attention kernel in Mojo at Python speed and get CUDA class performance on NVIDIA, AMD, and Qualcomm Silicon in the same file, the infrastructure engineer who translates research code to production kernels becomes optional, not immediately, not this quarter. But the direction of travel is clear, and the team shapes that emerge from that world look different from the ones that exist today. The honest signal to watch over the next 6 months is two things. First, does the Mojo compiler open source on schedule in fall 2026? And does the community treat it as credibly neutral under Qualcomm ownership? Qualcomm acquired Arduino in a prior cycle and maintained the open model, which is a useful precedent but not a guarantee. Second, does Max ship full MoE support? The models that actually matter at the frontier right now are mostly MoE architectures. A hardware-agnostic inference layer that doesn't run the dominant model architecture is a partial solution, and the ML ecosystem will adopt it as one until that changes. Lattner has built 3 foundational toolchains. He doesn't do things incrementally. Whether Mojo becomes the defining language of the AI era or another ambitious compiler project that arrived a few years too early is genuinely unknown. But a $3.9 billion acquisition from the world's largest mobile chip company, 3 weeks after a 1.0 beta lands, is not a sign that nobody is paying attention. Watch what the developers do. That's always the number that matters. See you in the next one.